Alright, welcome again in another tutorial of the topic differentiation. In this tutorial, we're going to see the derivative of the inverse. We're going to see the derivative of the inverse of reciprocals of trigonometric function. Kwa hiyo hizi hapa cosec ni reciprocal ya sine, sawa? One over sine is cosec. Na sec ni reciprocal ya cos. Na cot ni reciprocal ya tan. One over tan is cot. And this is why tunaziita reciprocals of trigonometric function. Lakini tunatafuta derivative of the inverse. Kama unavyoona hapo, it's y equals to cosec inverse of x. So, tuanze na hii ya cosec. So let's find dy dx. Okay, this is just the same as mtu aseme x equals to hivyo. So, dx dy is just going to be equal to negative cosec y cot y. So, if I reciprocate dy, kwa sababu natafuta dy dx, natafuta dx dy, it's just going to be negative 1 over cosec y cot y. So, my dy dx now, for y equals to negative, for y equals to cosec inverse of x, ni hiyo negative 1 over cosec y cot y. Lakini it has to be in terms of x. Remember, x is an independent variable. So, I know that sine squared y plus cos squared y equals to 1. So, if I divide by sine squared everywhere, like this, it's just going to be 1 plus cot squared y is equal to cosec squared y. So if I make cot y the subject, it's just going to be equal to cosec squared y minus 1. So my dy now dx is just equal to negative 1 over, so we have cosec y, and then we have the square root of cosec squared y minus 1. But cosec y ni nini? Ni x. Okay? Remember pale mwanzo. So dy dx itakuwa sana negative 1 over x squared minus 1. So hii ndo the derivative of what? Of cosec inverse of x. So now let's do one example here. I call this example 1. It says find dy dx if y is just equal to cosec inverse of 2x. So I'm going to use a chain rule. I'm just going to let w equals to 2x. This means that y equals to cosec inverse of w. So I'm going to get dy dx from the chain rule. It's just going to be dy dw times dw dx. So from this one, y equals to cosec inverse y inverse w. My dy dw nimetoka kuderive sasa hivi, so hapa badala ya x tuna w, it's just going to be 1 over w times the square root of w squared minus 1. Wakati from this one, w equals to 2x, my dw now dx is just going to be equal to 2. So from the chain rule now, my dy dx will just going to be equal to dy dw is negative 1 over w. This is w squared minus 1 times 2. So it's just going to be equal to negative 2 over w, kumbuka ni 2x, kwa hiyo badala hiyo naeka 2x, the square root of, kwa hiyo 2x squared ni 4x squared minus 1. So this one and this one, they go. So eventually now, my dy dx is just going to be equal to negative 1 over, I'm going to have my x there over 4x squared minus 1. So this is dy dx when y is equal to cosec inverse of 2x. So this one is my dy dx. So let's go to another one. It is sec. You have y is equal to sec of inverse of x. So my x is equal to sec of y. So what is dx dy? It's just going to be equal to sec y tan y. So now if I reciprocate, because I'm looking for dy dx, I just get 1 over sec y tan y. But we have seen earlier that tan squared y plus 1, we have seen in the previous tutorial. Hii hapa tuliona kwenye tutorial iliyopita. Kwa hiyo tan y kumbe nikimake the subject itakuwa ni sawasawa tu na sec squared y minus 1. So hapa badala ya tan y naweka hii. So my dy dx is just going to be equal to 1 over sec y times sec squared y minus 1. But sec y equals to x, so dy dx is just going to be equal to 1 over, we have x, and then we have x squared minus 1. So this one now is the derivative of sec of inverse of x. Now let's solve one example. It says, I call this example 2. It says find dy dx if y is just equal to sec of inverse x squared. So I'm going to use the chain rule, just going to let w equals to x squared. So y now is just sec of inverse of w. So from the chain rule, dy dx will just be equal to dy dw times dw dx. So from this w equals to x squared, I just get my dw dx is 2x. And from this y equals to sec inverse of y, nimetoka kuderive sec inverse of w, nimetoka kuderive sasa hivi, I mean dy dw itakuwa sasa na 1 over w, the square root of w squared minus 1. So my dy dx is just going to be dy dw is 1 over w squared minus 1 times 2x. So it's just going to be 2x over w squared minus 1. So what is w? W is x squared. So it's x squared, square root of w squared is going to be x power 4 minus 1. So this x and 1x here goes. So that's the final answer. dy now dx turns out is just equal to 2 over x power 4 minus 1. So this is the derivative for y equals to sec of inverse of x squared. Derivative yake ndo hiyo hapo. Now let's see for the final one. What is the final one? The final one is y equals to cot of inverse of x. So I mean, I find dy dx here. So this is just the same as you say x equals to cot y. So dx dy is just going to be equal to what? Nikidifferentiate cot y nilikuwa napata nini? What was the derivative of cot of y? It was negative cosec squared y, okay? Yeah, derivative ya cot x tuliderive kule nyuma ni cosec squared x, kwa hiyo ni hiyo hapo. So, I want to reciprocate. It's just going to be dy dx is equal to negative 1 over cosec squared of y. So I reciprocate because I am looking for dy dx and not dx dy. Well, I have seen that cot squared y plus 1 is just equal to cosec squared y. So dy dx, instead of cosec squared y, so I write cot squared y plus 1. So it's just equal to negative 1 over cot squared y plus 1. But cot y is equal to x, so cot squared y is just x squared. So dy dx is equal to negative 1 over x squared plus 1, or 1 plus x squared, yote sawa. So this one is dy dx when y equals to cot inverse of x. Now let's solve one example. So lazima hapa mwisho niweke x kwa sababu x is an independent variable. Ndio maana hizi y najitahidi kuzi eliminate. Sasa let's solve this example, the final example. I call this example 3. It says find dy dx if y is just equal to cot of inverse of tan of x. So I'm going to use chain rule. Again, just going to let w is equal to tan of x. So y is just going to be equal to cot of inverse of w. So I know dy dx is just going to be equal to dy dw times dw dx. So from this one, w equals to tan x, I'll get the w dx, which is just going to be what? Sec squared x. Okay, tusha derive huko kwenye video za nyuma. And then y is equal to cot inverse w. Tunataka kuderive sasa hivi. Badala ya w sasa ni, badala ya x ni w. Kwa hiyo dy dw itakuwa ni sasa na negative 1 over w squared plus 1. So I mean dy dx is just going to be dy dw, this one, times nini? Sec squared x. So itakuwa jibu ni sasa na nini? Negative sec squared x. Nikichukua negative 1 times sec squared x napata huyo. W ni nani? Ni tan x. So it is tan squared x plus 1. Wow. So I mean nimefika paka hapa. Dy dx is equal to negative sec squared x over tan squared x plus 1. Hapa chini ilikuwa w squared plus 1, but w is equal to tan x, so w squared is tan squared x plus. So w squared is tan squared x, so w squared plus 1 is tan squared x plus 1. But tan squared x plus 1 ni nini? Tan squared x plus 1 ni sasa na nini? Sec squared x. So dy dx is just equal to nini? Negative sec squared x over sec squared x. So hii na hii nakufa. So finally dy dx ni sasa na nini? Negative 1. So this is the derivative of y is equal to what? Cot inverse ya tan of x. So that is about the derivative for the inverse of reciprocals of trigonometric function. Let me just say, see you in the next tutorial.